Hello everyone and welcome back to Nice Lab. Today I'm here with another interesting application of AI, detecting whether a person is awake, drowsy, using deep learning. By the way, why do we need AI for drowsiness detection? So you can consider these two scenarios. So one is driver's alertness and second is workplace monitoring. So fatigue related accident can claim thousands of lives every year. AI can serve as a second set of eyes to monitor a driver's alertness. Same time, in the high risk environments like construction sites or control room, AI system can flag inattentiveness or sleep in critical zones. So traditional supervision is either not scalable or is prone to more human error. That's where AI come into the picture with 24/7 alertness, faster decision making, and high accuracy using just a camera and a trained model. So with that small introduction, let us go to our setup. So we have a folder which name as awake or drowsiness. You can see there are some files like IP by NP file. There are for model inference. You can see this is for model training. This is for model inference. And this is the saved model after training in H5 format. And I have a data file. So I trained a binary classification model using convolutional neural network. We call it as a CNN. This model trained almost 10,000 plus facial images categorized into awake and sleepy and is saved in the H5 format for inference in both images and video format. If you want to see the data, let us see how the data structure is for us. You can see the point here, data point here. So there is a folder called data. Then go to the folder train. I can see sleep and awake separate folder. Each consists of more than 5,000 plus images. And also there is another folder which called as challenge. In this challenge folder, we have some images for inference. You can see here, there are around 7 to 8 images for inferences and also we have a video. So now we will be checking how my model is going to identify whether it is sleepy or awake condition. Let us go to the code. So this is my code. Drowsiness model inference. We will be running one by one. As you can see here, we need some dependencies like OpenCV. I installed the OpenCV using a Pippin function and I imported some libraries like CV2, that is OpenCV, then NumPy for converting into arrays and some numerical computation, and use the TensorFlow for loading the model and also use the TensorFlow Keras for pre-processing the image. And next I set the path and define the class. So my path is under admin. This is the folder and this is the model name. I call the model as model noun and I have two classes. One is awake and another is sleepy. So next I am going to find the images from the folder. So it's from the operating system using the function list directory of Python, either JPG or JPEG or PNG file. I'm calling one by one files. Then I'm defining as connected with my model. So we resize the images if needed and we set the images in the model training as 150, 150. I am passing the same thing. Then I did some normalizing. After that, I'm calling this as a prediction function and converting to array before, of course. And this is our prediction of all images function. After that, I just give a note what kind of output is needed. I need label as awake and label as sleepy. Of course, some percentage confidence interval will also be displayed. And finally, it will be showing using the CV2 function. Let me execute this entire script. Yep, this is running now. This is generated couple of images. You can see from the output displayed on a separate window. There are two sample images, random pick. Two images say that both are almost sleepy but different percentage. I can see here it's almost 97, almost close. This is almost 5.4 chance is still awake. But this depends upon all again. a condition of the images given to the particular machine. And there is one more image you can see here, but this is going to say a wrong prediction. You can see it almost close, but still it is showing that 69% away. That's why AI can make mistakes sometime as well. So this is one node. AI sometime will be making some mistakes. So what do we do normally? We do some change of models, or we do some hyperparameter changes, which will be explaining in the last time of this particular video. And so can we apply the same thing to a continuous function like a webcam or a car or a factory kind of a concept? So the same logic, instead of images, we are passing a file called MP4 format. The name of the file is preview. So we do one changes, instead of directly calling the images, it actually load like a video, then converted using video capturing the video. Then we can read each video frames. Instead of entire video, the videos are converted into video frames and perform the inference continuously and live. So again, we load the video, we extract the frame, then we do the necessary pre-processing and feeding them into the model, and finally we annotate and display the real-time status, whether sleepy or awake. So let me execute this step as well. Yeah, you can see the video started playing. Unfortunately, first frame itself wrong prediction. Let us wait for the second. Yeah, this is almost 99 and 53% wake up chance. We will be moving to next frame. So I given some condition, what is the frame per second FPS. That's why there is some delay. So you can fine tune and change according to your requirement. So I don't want to spend too much time. We understood from this video how inference is taken from the model. We saved a model into H5 format and finally taken the inference using the H5 format. So this is just like a given as the phase changes. So now let's see how I train the model. That's very important. So we use this model in the inference. Now we are going to understand how we prepare the model. That's also very, very important. Where you have seen some misclassification or error in prediction. So here you can make the necessary changes to come out of this particular error. So we spend some time here. So we load the libraries, TensorFlow, Keras, image data generator, sequential model, layer architecture, and all the Keras layers. And then we set the path. We set the path under awake drowsiness folder, data, train, and I'm setting a path for the saved model as well. So I defined some parameter in the beginning itself. My image is going to be in a pixel value of 150, 150. For the training, I'm using a batch size of 32. Also for training, I'm considering 10 above. You can change all this and you can manipulate and do the necessary changes for your own model. Next, data augmentation. Hope you all knows about data augmentation. Sometime the 10,000 image or whatever I feeding into the training may not be sufficient. You may need to give different variety. So there is a good function, image data generator can multiply or generate images from the existing images, like rescaling and splitting, some kind of rotation, zoom in and zoom out, some shifting height bit changes, and sharing and horizontal flipping. All this maybe 3 times or 4 times of images can be prepared for the training purpose. So this is called data augmentation. After data augmentation, I need to pass the folder. So we know training, we need to understand what is the accuracy. We need to have 2 folder. One is train data, another is validation data. We will be using train underscore datagen flow from directory function to pass what is your data for train. This is train path. What is your target size? What is your batch size? And what is your class mode? We know this is a classification problem, categorical, and this is called training subset. And from the same data, we generated another subset called validation. We will train on the train data and we will validate the model on the validation. This is the purpose. You can see here almost 12,000 images for train and there are 3,000 images for the test purpose. Now we are going to define our layer architecture. So we will be calling as a sequential model with 3 convolution block. You can see a COM2D, COM2D, and another COM2D. These are the convolution blocks. each convolution blocks followed by a max pooling with filter size of 2 by 2. And we are giving the activation function in each and every convolution layer with a defined shape of 150, 150, and we are going to give another parameter 3. So we will be using this particular layer, and you can see the final layer will be a dense layer with the activation function softmax for classifying the data into two classes. Once the layer is defined, you can compile, but while compiling time, you are going to initialize what kind of optimizer you are going to use it. There are SGD, Adam. There are so many optimizer available. I'm using Adam, and I need to define what is my loss function. I know for model training time, there will be a decrease in loss function, and the purpose is going to increase the accuracy. So categorical cross entropy is the loss function which we are going to give, and the metric for measure the validation and the training is accuracy. So once the compilation done, so the major work is going to happen here only, model training. So for training, we will be using a function called fit. We will be passing the train data. We will be passing the validation data. Also, we are defining what is your epoch. We are giving 10 as an epoch. So it took almost 20 minutes to complete the entire training. You can see here the model accuracy, training accuracy is almost 0.91 and the validation accuracy is 0.71. You can see the loss function is decreasing. That's good sign. The validation loss is also decreasing, which is almost in proportion. I don't expect any overfitting concept either. So if you have overfitting problem, better do some changes in the dropout. This is one of the criteria can be adjusted for any kind of overfitting issue. And if you want to change more convolution layer, you can change optimizer function, of course. You can change the loss function. These are all the parameters you can adjust. We say hyperparameter, and also we can change the image size, batch size, epoch, everything for your own model setup to check whether model accuracy is increasing or not. So once the model is completed in training, so we save the model as a model and under the same path. So this is the entire convolution neural network based model training for detecting awake versus drowsiness classification problem. So now, if you summarize, we built a CNN model to classify sleepy and alert faces. That is the major activity. And use it for inference on static images and the real-time video. So we have seen on the model inference notebook, we have a separate extension for inferencing. And we highlighted how this AI system can be scaled into everyday use cases. Also, please note, this method works with cropped images because I have given in my training data as a cropped images. However, if your images or video containing multiple objects like a full face or full person, so we need to have a certain changes. We need to have an object detection first. You can use any method, MTCNN or whatever. So we will be detecting the faces or eyes and cropping the region of interest, and then we will be passing into the awake versus drowsy classifier model. This can be applicable to both static images as well as the real-time webcam or video feeds, allowing for continuous drowsiness detection. And as I mentioned, for betterment, you can add more data to the training, and you can change the model layer architecture, and you can update the model parameters as well. All these methods can improve the performance of your model. So that's it from me on this model for application of person awake or drowsy deep learning. Thanks for watching Kana is AI Lab. If this video inspired you, don't forget to like, comment, and subscribe. For more exciting AI builds are on the way. Stay tuned and keep exploring.